Okay, so let's talk about a new topic in database, which is normal forms. Okay, so let's talk about normal forms. Tell me, or before talking about normal form, let's talk about normalization. Why do we need normalization? Why do we need this thing called normalization? We need normalization because we need to reduce redundancy in a database. Okay, we need to reduce redundancy in a database. So the main reason for normalization is nothing but for reducing redundancy. Now what is redundancy? Can you explain? Yes. So if a row has duplicate values or a column has duplicate values, then we can say that the table is redundant. For example, let's say this is an SID, okay, this is SNAME, and let's say this is SH. Let's say this is some sort of student table. There is one guy whose student ID is 1, his name is Aman, and his age is, let's say, 20. There is one guy whose student is 2, then his name is Ankit, and his age is 22. There is one guy called One whose name is Aman and whose age is 20. And let's say there is another guy called Namit whose student ID is 3 and age is, let's say, 21. So can you tell me, is there redundancy in this database? Yes. How is the redundancy? See, this row is here also, here also. So we can see that this row is repeated. So as this row is repeated, we can say that there is a redundancy between row. So we can say that this is row redundancy. So if we want to reduce this row redundancy, then what we have to do? Normalization. Why? Because the goal of normalization is reducing redundancy. By reducing redundancy, that is removing duplicate rows, okay, removing duplicate rows or duplicate columns. Sometimes columns can also be duplicated. That will make the table much more redundant, as there will be very much redundant information which we don't need. Okay, so this is basically normalization, or yeah. So now we will be coming to normal forms. Okay, next, so this is one thing why we normalize. Next is ensuring data integrity. Okay, ensuring data integrity. So these are the two things that we do. Okay, so now we will be coming to, so these are the two main reasons why we normalize. Our first goal is to remove duplicate rows and columns, and our second goal is to ensure that the data is integrity. Okay, so now we will be coming to normal forms. How many normal forms are there? In total, there are 5 normal forms, but we will be studying up to the 4th normal form only. The 5th normal form is related to join and join dependencies, which is not that much required. So we will just study first, second, third, fourth, and DCNF, which is a stricter version of the 3rd normal form. Okay, let me just erase this. Okay, so we will be starting with the first normal form. So what is the first normal form? First normal form ensures that every cell in a table should be atomic. That means every cell should contain only a single value. Okay, so I'm just saying like this: every cell in the table should have a single value. Let's understand this with the help of an example. Okay, let's assume that there is one student table which has 3 columns: student ID, student name, and student grade. Okay, fine. Now there is one student whose ID is 1, whose name is Aman, and whose grade is 90, 40. Now there is one student whose ID is 2, whose name is Ankit, and whose grades are 50 and 60. And there is one student whose ID is 3, and let's say his name is Arjun, and his grades are 70 and 80. So if this is our table, can you tell me that all the cells are atomic or not? Tell me. Are all the cells atomic? The answer is no, all the cells are not atomic. We can see that if this is our table, this cell is atomic. A single value means atomic. Okay, atomic. Now we can clearly see that this one is atomic, this one is atomic, but this one is not atomic. Why? Because it has two values. Similarly, this has two values, this has two values. So is this database or is this table in the first normal form? The answer is no, it's not in first normal form. It is not in the first normal form. Okay, so in order to be in first normal form, every cell should be atomic. So how should I convert? How should I make it into first normal form? Just I can do something like this is just I remove this from here and I just wrote something like this over here. So tell me now, and also here I have to do those same things. So I will be making two more columns like this. Okay, like this. Now what I will be doing, I will be writing 2 and 3 Ankit and Arjun like this. Fine. Now what I will be doing is I will be removing this 60 from here. Okay, and I will be placing it over here, and from Arjun also I will be removing this 80 and I will be placing it over here. So now every cell has only one value. So now we can say that it is now first normal form, because every cell in this table has only one single value, that is atomic. That's why we can say that this table is in first normal form. Okay. Now the next thing is the second normal form, which I will be explaining to you guys. If they ask in the interview what is the second normal form, what you have to say, that I will also tell you, don't worry. Okay, don't worry. Okay, so now we will be understanding what is the second normal form. Okay, what is the second normal form? So see, basically in a table there are multiple columns and all the relation occur between the columns only. Okay, we know all those things. So let's say there is a table. If there is, the main thing is in second normal form there should be no partial dependency. Okay, no partial dependency. Now what is this thing? I will be explaining you, don't worry. Just keep this thing in mind. In second normal form there should be no partial dependency between the prime attribute and non-prime attribute. Now what are the non-prime attributes? Tell me what are prime attributes. Okay, so basically prime attributes are attributes of the primary key. Okay, who can basically identify all the tables in the database. Okay, let me explain you with the help of an example. Let's assume VW, there is one example which is, let's say VW tends to XY. Fine. Now there is one thing, Y tends to V. Now WX tends to YZ. Okay, so these are the things. Now can you tell me what are the relation schema is something like this: R V W X Y Z. So basically the collection of all the columns in the table makes the schema. Now can you tell me which are the candidate keys or the primary keys for this set of functional dependencies? So how will I do this thing? For that I have to take the closure. So let's take the closure of VW. So if I take the closure of VW, so V and W have, VW has V and W, so I can write V and W. Now from VW what I am getting, X and Y, so I also write X and Y. Now from Y what I am getting, V is already there. Now from W and X what I am getting, Y and Z, so Y is there, so I will write Z also. So from here what I can see that what are the values in the schema, V W X Y Z, and what I have got, V W X Y Z. So I have completely derived all the columns that are present in the table. So obviously this is a candidate key. You can say, because candidate key is a subset of primary key, so it's a primary key. So the attributes of primary key are known as prime attributes. So what are the prime attributes over here? That is nothing but V and W. V and W are nothing but the prime attributes. Okay, now let's see, is there any other primary key or not? Okay, see, there will only be one primary key in a table, but there can be multiple candidate keys inside a table. So the attributes of candidate key are also prime attributes. Okay, now let's say yeah, so if I do the closure of wx, will I get anything? Wx closure. So wx has w and x, so I will write w and x. Now wx tends to yz, so it's giving me y and z, so I will be writing y and z also. Now y is giving me v, y is present over here, so it has the power to derive v. So from here I can also get wx, v, y, z, everything, v, w, x, y, z. So this is also a candidate key. This is also a candidate key. So the possible set of candidate keys are nothing but wx and vx. Okay, now tell me what, there is one more thing also, you can also take wy. Okay, I'm not deriving that thing. Okay, so wy can also derive all the attributes in the schema. Now what I want to say is nothing but, so if these are the attribute candidate keys, now what are the prime attributes then? These are the prime attributes. What are the prime attributes? What are the prime attributes? The prime attributes are w, x, v, y. Okay, and what is the non-prime attribute? Basically the letters that are written inside the set of candidate key are the prime attributes. Now what is the non-prime attribute? The letter which is not written in the set of candidate key. Which letter is not written? It's nothing but z. So non-prime attribute is z. Fine. Now we have done till here. Now can we see, now what can we see that now if we can see that if there is prime attribute tending to a non-prime attribute, this thing is known as partial dependency. Okay, this thing is known as partial dependency. If prime attribute tends to non-prime attribute, then it is known as partial dependency. That means what? Non-prime attribute is dependent on the prime attribute. Okay, so if non-prime attribute is dependent on the prime attribute, then it is known as partial dependency. So here I can see, if you check this thing, so this is prime attribute, this is prime attribute, this is prime attribute, this is non-prime attribute. Now you have to clearly think this, which is non-prime attribute multiplied by prime attribute will be equals to non-prime attribute only. Okay, so from here I can say that this is nothing but prime attribute, and from here I can say that this is nothing but a non-prime attribute. So as this prime attribute is tending to non-prime attribute, we can say that partial dependency exists, and as partial dependency exists, we can say that this thing is not in 2NF. This thing is not in 2NF. Okay, I hope you have understood. So basically there should not be any partial dependency. That means no non-prime attribute should be dependent on any primary attribute. Okay. Now see one thing. Now the next thing is third normal form. We will be doing some questions on normalization as well, so don't worry. I hope those things, after doing those questions, everything will be clear. Okay. Now let's start with third normal form. So what is third normal form? Third normal form is a stricter version of normal form. Okay. So see one thing, if a relation is in third normal form, then it is definitely in second normal form as well as first normal form. So if it is relation is in second normal form, then definitely it is in first normal form. If a relation is in BCNF, the stricter version of third normal form, then it is definitely in third normal form, second normal form, first normal form. Okay, so this is a very important thing which you need to understand. Now see, what is third normal form? In third normal form, if there is something like this, there should not be any transitive dependency. Okay, for a set of relations to be in third normal form, there should not be any transitive dependency. Now what I mean by transitive dependency, see one thing, let's say student ID tends to student name. Okay, and student name tends to or is dependent on let's say student age, just a random hypothetical relation, and our student table has just these things, and our student table has only three things: SID, SNAME, and SH. So tell me one thing, if student ID is dependent on student name is dependent on student age, then can we say that student ID is also dependent on student age just by looking at the relations? Can we say that student ID is dependent on student age? Yes, obviously, because here what I am saying, A is tending to B is tending to C, then we can easily say that A also tends to C. So this thing is known as transitive dependency. This thing is known as transitive. I don't know whether it is visible or not. Yeah, it's visible. So this thing is transitive dependency. Now if a relation has transitive dependency, then it's not in third normal form. For a relation to be in third normal form, there should be no transitive dependency. Okay, I hope you have understood what is a third normal form. Now the next topic is BCNF. Okay, the next topic is BCNF. What is the full form of BCNF? The full form of BCNF is Boyce Codd normal form. Okay, let me write it for you guys. Boyce Codd, BOYCE, Boyce Codd normal form. Okay, so there is a very stricter version of normal form. Okay, so let's say there is a set of uh, like relations like R, A, B, C, D. This is the schema. Okay, so here let's say these are the functional dependencies. A tends to B and C tends to D. These are the two functional dependencies. So obviously every time the left side should be a super key. Left side should be a super key. Left side should be a super key all the time. Okay, let's assume this is a super key, A is a super key and C is a super key. Then this one is in definitely in BCNF. But let's assume A is a super key but C is not a super key. Then this is not in BCNF. If this is not a super key but this is a super key, then it is also not in BCNF. For a relation to be in BCNF, how many the total number of relations which are there, every relation's left side should be a super key. Okay, then only it will be in a BCNF form. Okay, so it's a stricter version of third normal form. Okay, I hope you have understood. Now let's do some questions on these normal forms, which will make it much more clear. Okay, so a super key is also a candidate key. We can also say it is super candidate key or a primary key. You can say anything. So let's see. Let's see with the help of an example whether a relation is in BCNF or not. Okay. So there is one relation given. The schema is something like this. So there is a relation R with three attributes A, B, and C. Okay. Now what are the relations that are given? A tends to B, then next is B tends to C, and C tends to A. Now tell me, is this relation is in BCNF or not? Tell me, is this relation is in BCNF or not? So for seeing that whether a relation is in BCNF or not, what I said that left side should always be a super key. Now how will I understand whether it is a super key or not? By taking the closures. If the closure of this can give me all the attributes, then it's a super key. If the closure of this can give me all the attributes, then it's a super key. If the closure of this can give me all the attributes, then this is also a super key. So if one of the left side is not a super key, then it's not in BCNF. Fine. So let's take the closure of A. So the closure of A is giving me A, then from A I am getting B, and from B I am getting C. Yeah. Now let's take the closure of B. So it's confirmed that A is a super key. Let's check for B. Now what is the closure? B's closure is obviously B. From B I am getting C, and from C I am getting A. So all the three attributes are derived. So this is also a super key. Now let's check for C. So closure of C. C is giving me C. From C I am getting A. Okay, and from A I am getting B. So from here also all these three attributes are defined. Oh, I'm getting. So this is also super key. So all of the left side is a super key. Then I can easily say that this is a BCNF relation. Okay, fine. Okay, now we will be doing some practice questions on the normal forms.